to find all the subsets of a given string. So suppose we have ABC as given string, we will output a list of all its its subset string. If the ABC, if we are given a zero length string, we will return the list with a zero length string inside. If we are given a null, we will return the list of empty. So we will first make an assumption that there is no duplicates in the original set. We're going to solve this problem with a recursive way. So suppose we have this ABC as the input string. We will have a recursion tree with 3 layers, which represents the 3 elements will be added on the result or not. So we have recursion tree like this. For the first layer, we will consider the first element A. So we have 2 cases: if the A is added to the subset, or A isn't added to the subset. For the second layers, we consider if the B is added in the subsets or not. So in the last layer, we will have all the leaf nodes as our result. We need to save those strings in a list. For the coding part, we're going to make the signature of this method. We will take a list. We will return a list of string as a result, and we will use this input string as the parameter. And first, we will build this the list of string result as a new list, as a new array list, and we will take this, and we will put the subsets inside. First, we will enumerate the corner case, and after that, we will transfer this input string into a character array. Also, we will define a index 0, which represents the layer of the recursion tree. Also, we need this string builder to determine if the element is added or not. And then we will call up a helper function to find out all the subsets and store them in the list. So for this helper function, we will use the array string builder, the result, and the index as input. And if first we will consider this base case of the recursion. So it's when the index equals the length of this string, we need to terminate this recursion, and we add the result into we add the substring into the result. And if it's not the base case, we will either need to append the next character or not append the next character. So in this part, we're appending the next character, and we go to the next level of recursion. And after that, we need to come back, and we need to delete the character we just appended to get the other possibility that the character is not added in this substring. And we also goes to the next level of recursion. For this method, we will have the time complexity as the total number of recursion nodes. So the the number of the nodes on the recursion tree should be at the magnitude of n. And and the space complexity should be the height of this recursion tree, which is also n.